11. So I'm going to complete the corrections for you from number 6 to number 10. I'm just going to read through the questions. So please follow in your books on page 22 and 23. So as you can see, number 6 states, a crate is sliding down a slope against friction at a constant acceleration, right? So as you can see, here is our body diagram or our force diagram showing the crate that is on the slope. Okay, so it's sliding down the slope. So obviously the applied force is going to go in this direction. Okay, remember we need to represent our force parallel and our force perpendicular here. So because it's going down the slope, our parallel force is going to act in this direction here, right? So this is our F parallel, right? And our perpendicular is going to act in this direction here, right? So this is our F parallel. Then we have our normal force, right? It's the force going straight up, right? Which is equal to our force perpendicular. And if you look at the question, it says a crate is sliding down a slope against friction. So that means that friction is present in this case. So friction will act in this direction here, right? And remember we represent it with a small f. Okay, now time to draw the free body diagram. We have, and remember I told you that it also needs to be on a slope. Okay, so we're going to represent it like this, right? So it is also on a slope. So here we have our perpendicular force, right? This way we have our force parallel. Here we have our normal force, and in this direction here we have our frictional force. Okay, learners, looking at number 7, please view the question in your books as I'm reading it. A block on a rough surface, right, which is here, because it's a rough surface, we know that friction is going to be present, joined by a string. So here we have a string passing over a pulley attached to another block. Here's our second block. The system accelerates clockwise, right? So in a clockwise direction, that means that force, right, is moving in this direction here, okay, towards the right. Now, like I told you guys yesterday, when we have two objects in question, you will draw separate force or body diagrams and separate free body or free force diagrams. But for now, I'm just going to represent it on here to show you guys. But obviously, you are going to draw it separately, okay? Right. So we are firstly going to look at this 3 kg block. Now, obviously, it's moving in this direction here, okay? And because it's moving, this string here is experiencing tension force, okay? So obviously, we know that we have the force, the gravitational force pulling this object downwards. Because it's on a rough surface, because acceleration is towards the right, our frictional force is going to act in the opposite direction. Okay, we know that we are experiencing a normal force from the surface, and here, right, instead of it having an applied force, tension in the string is what is causing this block here to move. So tension force is pulling this block, this 3 kg block. This string is under tension force, okay, right, because it is being pulled. When it comes to this 5 kg block, okay, now this is very simple. The only two forces that are acting on this block is our force of gravity, right, and tension, which is moving in an upward direction because it's being pulled. You understand? Right. So these are the only two forces that are being experienced, right, by this block here. Okay, now if we want to represent it, if we want to represent the 3 kg block, using our free body diagram, we have how many forces acting on it? 1, 2, 3, 4. Okay, so we have our weight, right? Our normal force, our tension, and our frictional force. When it comes to this 5 kg block, our free body diagram is going to look like this, right? We have our weight acting on it and our tension force, and that is it. Now let's look at question 8. Okay, right, look in your textbooks. 2 blocks on a frictionless surface, right? There is no friction on the surface here, so we will not represent friction. Accelerate to the right, so it's telling us that direction of motion is to the right. Okay, so this is obviously going to be our applied force, right? So because force is being applied here at A, right, this force is pushing A, so A is going to exert a force on B and B is going to exert a force on A. Okay, right. Now as you can see here, I've drawn it separately because like I told you, the body diagrams, they need to be drawn separately so we can represent it, right? I couldn't really explain it on this one because then you would not understand. Okay, so as you already know, right, these objects here,